Hello guys, welcome to my QR factorization class. Actually, QR factorization is one of the method comes under inner product space. This QR factorization is very easy whenever we are very clear how to apply Gram-Schmidt method. Once you clear the Gram-Schmidt process, then it's very easy to understand QR factorization. Now, let us try to consider the theory part of QR factorization. After that, we are going to take on some problems based on QR factorization. See, QR factorization is, I told very clearly, is a very easy once you clear the previous videos for Gram-Schmidt process. The continuation of Gram-Schmidt process, we get QR factorization. Yeah. The QR factorization is a linear algebra operation, algebra operation that factors, this is factors a matrix into an orthogonal component which is a basis for the row space of the matrix and a triangular component. They divided into the given matrix into two matrix, factor into 2 q into r. Q is nothing but is a matrix into that matrix having a orthogonal component. This is a which is a basis for the row space of the matrix, and also another matrix R is a rectangular components. They totally the given matrix divided factorized into two. One is Q and R. Q is having orthonormal basis for the matrix. They having a column, and R is having a rectangular matrix. They having a rectangular component, means they having a rectangle R is a rectangular matrix. Therefore, total is divided into factorized into how many matrix? Two, Q and R. Yeah. If if A is an M cross N matrix, they given a matrix, they having M rows with N columns. With linearly independent columns, they're talking about columns are linearly independent, then A can be factorized as A is equal to Q into R, where Q is a M cross N matrix whose columns form an orthonormal basis of the columns of A. You form a column sub Q is M cross N matrix whose columns are formed from an orthonormal basis for the columns of the matrix A. And R is N cross N upper triangular matrix with positive entries on its diagonal. In the diagonal, always you are expecting the entry must be a positive. Yeah. Before moving to the next step, please try to understand if A is a M cross N matrix, okay, with the matrix having what type of matrix you are expecting, with linearly independent columns, then A. Yeah, you have a matrix, you can't convert directly that every matrix is Q into R. Each of the column of the matrix is must be a linearly independent. You already know that what's the definition of linearly independent. Then only is possible I have to factorize A as Q into R, where Q is a M cross N matrix whose columns form an orthonormal basis for the columns of the matrix A, and R is N cross N upper triangular matrix with positive entries on its diagonal. Only worried about positive entries in diagonal, but other than diagonal value may be a negative, but keep in mind that R is a upper triangular matrix. Now, A equals what we decided. A can be written as what actually? A is nothing but Q into R. A is nothing but what? Q into R. Okay. A is Q into R. Then I am going to take Q transpose on both sides. Q transpose into A is equal to Q transpose of Q into R. Q is a matrix formed for orthonormal basis for the column vectors of the form from the columns of A. And R is a upper triangular matrix with diagonal entries are positive entries. Then this is from the associative property of matrix. Either I to group these two or group these two does not matter, because A into BC is nothing but AB into C. That associative property holds good under the multiplication. Therefore, I'll group these two. I'll write it this is I, because A is what actually? A is form. A is a M cross N matrix whose columns form an orthonormal basis for the columns of A. Each column is orthonormal basis. Is orthonormal basis means it must be a orthogonal. Whenever matrix is orthogonal, from the basic concept of matrix, the Q transpose into Q is equal to identity matrix only when Q is an orthogonal or orthonormal. Because orthonormal is a orthogonal, but orthogonal need not be a orthonormal. You already know that. Yeah. Now here is orthogonal matrix. Therefore, what is Q transpose into Q is nothing but I. I into R. Identity matrix into R itself is R. Therefore, Q transpose into A is equal to R. Then what we get R? R is how we get R? Q transpose into A. The entire story of this QR factorization is, if we want to apply QR factorization method, one point we have to observe. In the matrix, each and every columns of the matrix are given matrix are nothing but linearly independent. Once is linearly independent, then next you find out orthonormal basis for the given matrix of A. You take it each column of the vector. Then you use Gram-Schmidt process to find out orthogonal set. From that we get orthonormal set. Then each vector you write it in the column of Q. Write it in the column of Q is nothing but each column of Q is nothing but orthonormal basis for the columns of A. Yeah. After that, how then we get Q. How to find out R? We are using a formula for R is what? Q transpose into A. Then we get R. Once we get R, for your cross check, what we did Q and R is correct or not, we get immediately, we have confident to say that I get a full marks or not. You multiplied with what we get R with along with Q. Here, once you get A, then we say that what you factorize A into Q into R is correct. Otherwise not correct. And also, while finding R, keep in mind R is upper triangular matrix, but diagonal entries must be positive. You have to take care for that. Suppose R is, we get an upper triangular matrix, but any one of the value in the principal diagonal value is what about that negative value is not a positive, then you have to recheck. Maybe you done somewhere mistake. You suppose you satisfy these two conditions and then you multiply Q into R is equal to get A. Yeah, before moving to the next step, what are the steps I have to follow for to factorize the given matrix into Q into R? First you observe the given matrix A. In each of the column of the matrix is nothing but linearly independent. You pick the column for A of the given matrix, that is nothing but vectors, say V1, V2, etc. Vn. Apply Gram-Schmidt method to process to find out orthogonal set. From that we get orthonormal basis set and also corresponding orthonormal basis. Each orthonormal basis vectors are nothing but columns of Q. This is a way to form Q. Once you form Q, take transpose of Q into A. But keep in mind, A into B is not equal to B into A. Commutative property does not hold good under the multiplication. Always you take A after Q transpose. You simplify that, you are expecting A. But A is what type of A you are expecting now? A is nothing but actually, what is A? Q transpose into A we get R. R is a upper triangular matrix, but what about positive entries on its diagonal? That's the way you are expecting. Once you multiply Q into R, definitely we get A. Then only say that what you factorize A into QR is nothing but is correct. That is the method for QR factorization. I think everyone is clear for this. I'm moving to the next, how to solve the problem by using this. Okay? Yeah. The next step is, we are going to use the next step, problems. First problem. Yeah. Observe carefully in this problem. Yeah. It's very easy. The problem is, yeah. Problem is very easy. Suppose you clear Gram-Schmidt process. Find the QR factorization for the matrix A. They having 1 1 1 1 and 0 1 1 1 and 0 1 1 1. Then these observe how many columns you have, 1 2 3. Once you write the vector, we get 3 vectors, v1, v2, v3. Observe all 3 vectors are linearly independent. Therefore, it's possible I go for QR factorization. If you want to do the QR factorization, I told first you Pick the each columns are nothing but V1, V2, V3. First you pick this is V1, this is V2, this is V3. Once you pick V1, V2, V3 and sorry, first you pick these are X1, X2, X3. Yes, these are X1, X2, X3 are the vectors. From that, by using Gram-Schmidt process to find out V1, V2, V3. First we have to same thing what we already know that already I discussed this problem in Gram-Schmidt process. Even though I am going to explain, then we get a what about revision for that. First we have to find vectors V1, V2, V3 are the corresponding vectors of X1, X2, X3 by using Gram-Schmidt process. You know what are the formula, you are already familiar with. V is equal to X1, what is V2? X2 minus inner product of X2 comma V1 divided by inner product of V1 into V1. What's the formula for V3 is X3 minus inner product of X3 comma V1 divided by inner product of V1 minus inner product of X3 V2 divided by actually this is V2 it's wrong actually V2 yeah into V2. Actually inner product of V2 comma V2. I'm going to change, this is V2 actually V2. Then what is my V1? V1 is nothing but what actually? X1. What is X1 here? You already know that in the given what is X1? 1. Yeah. Next I have to find out what actually V2. While finding V2, V2 inner product of X2, I have to find out which value first. X2 inner product of V1 is nothing but is a column vector. This can be written as X2 transpose into V1. What is X2? They given 0, 1, 1, 1. That's a row into column. This is a vector. Multiply that, we get 3. And then find out inner product of V1. What is inner product of V1? V1 transpose into V1 is 1 square plus 1 square plus 1 square plus 1 square. We get 4. Yes. Then I have to substitute these values where in this one. Where actually I have to substitute these values where actually in V2. V2 must be equal to X2. What is my X2 is nothing but 0, 1, 1. I have to substitute 0, 1, 1 minus X2 inner product of X2 V1 is 3 divided by what is the value of inner product of V1 is 4. 3 by 4 into V1. This is V1. Simplify that, we get this is a vector for V2. Similarly, I have to find out which vector? V2 vector. If you want to find out V2 vector, what's the thing I want to find out here? First you find out inner product of X3 comma V1. X3 transpose into V1. X3 is they given already in the problem. What is they given 0, 0, 0, 1. From that I had to find out 0, 0, 1 into 1, 1, 1 is because V1. Simplify that, we get this. Similarly, to calculate inner product of V2 comma V2 is nothing but V2 transpose of V2 is nothing but you multiply. Then V2 transpose means you just know what is V2. Take in row into column. Multiply that. After the simplification we get 3 by 4. Once we get 3 by 4, what's the next is inner product of X3 into V2. X3 into V2 is nothing but X3 transpose V2. Again I have to take row, X3 row into a column. Then simplify that, we get 1 by 2. Therefore, now I have to substitute these values where in V3. What is V3 actually? V3 is nothing but 0, 0. This is nothing but X3 minus inner product of X3 comma V1 is 2. Just now we calculated is 2 divided by inner product of V1 comma V1 is 4. 2 by 4 into V1 minus inner product of X3 comma V2 is 1 by 2 divided by inner product of V2 comma V2 is 3 by 4 into V2. This is V2. Okay. Then simplify that. Finally we get this is our vector. Are you clear? This is a vector a little bit fast because you know all the steps. That's why I'm explaining little bit fast. Now after the simplification we get this. Okay. Once we get that these things you already know that where in the Gram-Schmidt process, and then I move into the next one is nothing but V1. Yeah. From that, what are V1, V2, V3 we get? I am going to write what are V1, V2, V3. What is our V1, V2, V3? This is V1, V2, V3. I have to verify whether it is orthogonal or not. How to verify? Take inner product of V1, comma V2, calculate inner product of V1, comma V3, and then inner product of V2, comma V3. It's nothing but V2 transpose V2, V1 transpose V3, and then V2 transpose V3. You know how to calculate this part. Already explained in Gram-Schmidt process. Then all are 0, then we say that therefore V1, V2, V3 are what actually? Orthogonal set. Orthogonal and also non-zero vectors, because V1, V2, V3 are clearly non-zero vectors. Yeah. And the next, therefore, thus V1, V2, V3 is a non-zero orthogonal set. We know that non-zero orthogonal set is a basis, hence V1, V2, V3 are is a orthogonal basis. But Q is nothing but the columns of A for the orthonormal basis of A. Columns of A. Next, try to find out orthonormal set. How to find out orthonormal set? We already discussed in the previous video. U1 is equal to V1 divided by norm of V1. U2 is nothing but V2 divided by norm of V2. And then U3 is nothing but V3 divided by norm of V3. You know how to find out what about that norm of V1, norm of V2 and norm of V3. Norm of V1 is nothing but square root of square of each of the value. V1 value 1 square plus 1 square plus 1 square, we get 2. Norm of V2 means square of the each of V2 value. You already know that this is V2. Similarly, I have to take square of each of the value of V3 is nothing but norm of V3. Square root of that, simplify that, we get this is a value we get. Yes, this is a value we get. Once we get this value, substitute in U1. I have to divide V1 by 1 by divide the V1 by 2, divide V2 by root 3 by 2, divide V3 is nothing but root 6 by 3. We get finally these are the vectors for U1, U2, U3. Once we get U1, U2, U3, then I have to find out is a orthonormal set. Orthonormal set means inner product of Ui, Uj is equal to 0 for I is equal to j. Inner product of Ui, Uj is not equal to 1, I is equal to j. Then we say that is orthonormal set. Yeah, similarly I have to find out what's the inner product of U1, U2. Is we get 0, inner product of U1, U3 also 0, inner product of U2, U3 also we get 0. This shows that these are orthogonal, but I want to verify is a orthonormal, means further I calculate the values of what actually U1, inner product of U1 comma U1. What's the inner product of U1 comma U1? Inner product of U1 comma U1 is nothing but 1. Here we get inner product of U2 comma U2, we also get 1 after the simplification. Similarly, inner product of U2 comma U3, what we get is 1. This shows that U1, U2, U3 is a non-zero orthonormal set, hence is a orthonormal basis for the inner product space. Now we have to write what is my Q. U1 is the first column of Q because these are orthonormal basis for A. We have taken columns of A, you find out the orthonormal basis. The form of Q is a columns of orthonormal basis of columns of A. U1, U2, U3 substitute. Once we get to take a transpose. Transpose means what? Row into column. Yeah, row into column I written. See, row into column. Then what is our Q transpose into A? Write Q transpose, you have a value they given in the problem, you substitute and row into column you have to multiply. Row into column, multiply. Now this is the first element, you know how to multiply two matrices. You multiply this, written each and every value, multiply. Row into column, 3 column, we get 3 values. Second row with 3 columns, third row with 3 columns, we get again 3 cross 3 matrix. After the simplification, we get R. R is a upper triangular matrix. Diagonal entries must be a positive. Not for non-diagonal. Diagonal entries must be positive and upper triangular. It satisfies. And before going to wind up this problem, I want to know whether I convert the factors Q and R is correct or not. I have to multiply Q and R. Then this is students, they doing mistake. Even though don't get it after multiple Q and R, they simply writing A. But keep in mind, everyone, they are very sharp compared to you faculties. They already knows what they expecting Q, what they expecting R. You can't expecting more than that. We are expecting Q R must be unique. Suppose you did correctly. Okay, once you multiplied that row into column, definitely after I multiplied only, I verified only, I written this. I am not written directly. Okay, I did calculation in separate rough book and then I substitute the value. This is VGA. Then I confidently say that what I done, solution is correct. Easily score the marks for 10 marks for this. This is a way to find out This is a way to A is factorized into Q into R. That method is called QR factorization. Q is nothing but column orthonormal basis for the columns of the given matrix. R is a upper triangular matrix with whose diagonal entries are positive. Now, if you want to do that, the given matrix, each of the columns are linearly independent. Then only possible, and only is possible to convert the given matrix into Q into R factorization. Okay, thank you very much for listening. I'll come and take next class in some more problems. Thank you. Bye.